All right, so what energy comes from the sun? So here we see this beautiful picture that flowers blooming and that nice beautiful rose. And the sun gives us energy, and that energy takes a couple different forms. Now, first off, it gives us light, that beautiful light energy that we see coming from the sun, which enables us to see outside. But it also gives us some heat. So you know that when you're outside, the sun shines on you, you feel warm. Well, the light energy from the sun and the heat energy from the sun are two different types of energy that the sun gives off. There's also some others, such as ultraviolet radiation. You know, if you stay out in the sun too long, you might get a sunburn. So that's UV rays coming from the sun. So the energy from the sun takes different forms. So if we take a look at the page that's similar in your notes, we could draw the different types of energy that comes from the sun. So I'm going to draw here's some visible light energy coming from the sun. It's traveling, it's 92 million miles from the sun to the earth, hits the earth and gives us visible light. But there's other types. So the heat energy that comes from the sun, you might know by another name, we call that infrared. That's heat energy, and that's what we get, what we use when we use night vision goggles, is infrared energy. It's the heat that's given off. And that heat energy also travels from the sun to the earth. And then we also have some ultraviolet energy that travels from the sun to the earth. So that's our UV rays, ultraviolet energy. You'll notice that I drew them a little bit differently, not just their colors, but the length of the waves that I drew are different for each of them. That's because this energy is different because of their wavelengths and how they're different. And there's lots of other energy that comes from the sun too. It's not just these three. All of this energy is called the electromagnetic energy. Here we have visible light, ultraviolet, and infrared you see on the chart. But the sun also gives off gamma rays, X-rays, microwaves, and radio waves as well. So the sun gives off a tremendous amount of energy. We see the light and we feel the heat, and if we stay out long enough, we can certainly see the results of the ultraviolet. But this other energy is also given off by the sun as well. You could see the same chart if you take a look at your Earth Science reference tables and you open up to page 14. You'll see this chart right here, which gives you the entire electromagnetic spectrum. So that's all the electromagnetic energy given off by the sun. And although the wavelengths are not given to you, they do show us that the energy to the left is decreasing wavelength. So the energy to the left over here, the energy to the left over here has short wavelengths, decreasing wavelengths. So the wavelength there is short, and the wavelength on the right-hand side tends to be very long wavelengths. Now let's talk about what wavelength is and what that means. The wavelength is the distance from the top of a wave crest to the top of the next wave crest. So here's a wave, and this energy always travels in a wave-like pattern, and the wavelength is the distance from the top of a crest of a wave to the top of the other crest of the wave. So that right there is the wavelength. If I drew another wave, one that has a shorter wavelength, it looks something like that. You'll see that the distance from the top of one crest to the next crest, that is a little bit shorter. So it's a shorter wavelength. So we could simply look at this chart and say, oh, well, ultraviolet rays, ultraviolet energy from the sun has a shorter wavelength than infrared energy from the sun. We could also do that just with the colors of the spectrum. You see that blue light here is towards this side, towards the left side of the chart. So blue light has a shorter wavelength than, let's say, red light, which would have a longer wavelength since it's on that side of the chart. And all this different energy is really the same thing. The only thing that's different about it is the wavelength, the distance from the crest to the crest. You know that ultraviolet rays are very different than infrared. Microwaves are certainly different than gamma rays. Radio waves are different than X-rays. They're all very different. They have different characteristics. And the characteristic of that type of energy is based on the wavelength. The only thing that's different between green light and orange light is the wavelength. The only thing that's different between the energy, the microwave energy that pops your popcorn, the X-rays that you are used by your dentist to take X-rays of your teeth. The only difference is the wavelengths. That's the only thing that's different between them. Here, take a look at this question here. Energy is transferred from the sun to the earth mainly by what? Go ahead and hit pause if you need a second to look at it. Correct answer is electromagnetic waves. So the energy coming from the sun is all electromagnetic waves. If we wanted to, we could then add to this chart right here. Not only do we have infrared energy coming from the sun, we have some really long radio waves. We have some super small wavelengths of some gamma rays. I can't even finish that. So all of the energy coming from the sun is all electromagnetic energy. We call it the electromagnetic spectrum. You've heard the word spectrum, just talking about visible light, right? The visible light we know is the Roy G. Biv, right? Red, orange, yellow, green, indigo, and violet. It's a spectrum, and the spectrum continues beyond what you and I can see to the infrared, the ultraviolet, and the gamma rays as well. So for this, what energy is electromagnetic energy? How about this question here? Which color of the visible spectrum has the shortest wavelength? Which color of the visible spectrum has the shortest wavelength? Violet, yellow, blue, and red. So let's go back to our Earth Science reference tables. And so here we see page 14 of the reference tables. Violet light number 1 is here. Yellow light number 2 is here. Blue light number 3 and red light number 4. We said before, if this is decreasing on this side, decreasing means the waves over here are going to be shorter when we head to the left. Where we're on the right hand side, these waves over here are going to be longer since they're increasing in size. All right, so which one, in this case here, the question's asking us for the shortest wavelength, so we're going to pick the wavelength that is closest to the left-hand side. In this case, it happens to be, of the 4, violet light. So the correct answer to that is number 1, violet.